Hi, in this video, I'm going to talk about inverse function, okay, which is section 5.3 from the book, all right? So it is basically, it's a kind of revision from college algebra because you have seen inverse function in college algebra, okay? And we will see some application of the inverse function and then we'll review that, all right? Okay, so in college algebra, you see that suppose this graph, the black or the brown, you say this graph is the graph of function fx. Then the inverse function is its reflection about y equals to x line, right? This is y equals to x, this is dotted line. And then the inverse of the function fx is the mirror image. It's like a reflection about this line. So the image of the reflection of this is seen here, the reflection of the point here. So the reflection of this curve is that piece, the reflection of this piece is that piece, and this piece is that piece. So overall, this blue curve is the inverse of the function fx. So the notation is, if fx is the original function, then how do you write the f inverse? It's just f and then -1 and then x, right? It's f to the -1 like that. So f inverse x. So this is x-axis, this is y-axis. This is the line y equals to x, okay? So what are the steps? Do you remember what are the steps to find out inverse of a function? It is like y equals to f of x will be given to you, and then you swap x and y. Instead of y, you write x. Instead of x, you write y, and then you solve for y. That's what you do, okay? We'll see an example. And then, so what was the condition that a function has an inverse function is f of x has an inverse function if f is 1 to 1. Meaning that we do the horizontal line test, right? You see that, does this function has inverse a function? Yes, because if you do a horizontal line test, everywhere you draw the horizontal line, it crosses the black curve in only one place, right? So it is a 1-to-1 function. That's why its inverse, which is this blue curve, is a function, because you can try vertical line test to see if this blue curve or the blue and green, this is like I'd say, I don't know, it's not a blue, it's like light blue, right? This function is this curve is a function. The graph of this curve is a function as well, because the horizontal line cross the vertical line cross only once. It is a function. To check a function in the graph, you draw a vertical line. If it crosses more than once, it is not a function. If it crosses only once, it is a function. To check if a function is 1-to-1 or not, you draw a horizontal line, okay? If a horizontal line crosses only once, it is function, otherwise it is not a function. Now, there is another way to check if a function is 1-to-1 or not. If a function is increasing, it is 1-to-1. We call monotonically increasing, okay? If a function is monotonically increasing, how do I know that the function is monotonically increasing? You know that, right? In Calc 1, if the first derivative is greater or equals to 0, it is increasing. If first derivative is less than 0, then f is decreasing, right? If it is positive or 0, greater or equals to 0, it is increasing. If it is negative or 0, it is decreasing, right? If a function is monotonically increasing, we also call monotonically increasing or strictly increasing or decreasing, then it has inverse function, okay? If a function is strictly increasing or strictly decreasing, then the function has inverse function. Otherwise, the function does not have inverse function, okay? That's the another thing that we can check, okay? All right, if a function is strictly increasing or decreasing, then it has an inverse, otherwise it does not have inverse, okay guys? All right, so let us do some problems and then it will be clear to you guys, okay? So if the function fx is monotonic and has an inverse, okay, that's the question. So we want to find out the derivative and then see if the derivative is strictly increasing or decreasing. What is the derivative of this function cosine? Do you remember the formula? If f of x, what is the derivative of cosine of u? Okay, f of x equals to cosine of u, then f prime will be negative sine u times u prime, right? So that's what the u is. It's like cosine u. So what is f prime? Is sine u times u prime is 3/2. What do you think? So that is u is basically 3x over 2, right? So let's write down. So sine 3x over 2 and then 3/2. That 3/2 I wrote on the front, right? So that is 3/2. Basically it is negative also. I forgot that negative sign, okay? So negative 3/2 sine 3x over 2 for all x. But does this function increasing or decreasing? If you graph this function, then it will show some fluctuation there, right? So this function is sometimes increasing, sometimes decreasing, increasing, decreasing. So it does not show increasing everywhere or decreasing everywhere pattern. So this function is not monotonic, okay? Not monotonic. Monotonic. Monotonic means tonic. So monotonic means monotonic, strictly increasing or decreasing. Is this strictly increasing or decreasing everywhere? No. In some piece it is increasing, some piece decreasing. So it is not monotonic everywhere on negative infinity to positive infinity, because the question is asking so that if the function is monotonic on negative infinity to positive infinity. Okay, that's the question. So since this is not monotonic, so it does not have inverse. So the answer is no, not inverse. No inverse. This function does not have inverse in this interval. Okay. Next, part B. So let us find out what is f prime. F prime will be 3x squared minus 12x plus 12, right? So let us simplify this. It is 3x squared minus 4x minus 4. If you simplify this, you will get 3x minus 2x minus 2. That will be basically 3x minus 2 square, right? This square function is in positive everywhere except at x equals to 2, right? If x is different from 2, it is always positive, right? So that is greater or equals 0. At x equals to 2, it is equals to 0. Otherwise, it is always greater or equals 0. So f is monotonically increasing. Since it is monotonically increasing, so it has inverse, right? So f has inverse. So you can say that way. Okay, guys? So let us do another problem. Let fx is 9 minus 5x. So find f inverse x. So to find out the inverse, you write y equals to 9 minus 5x. Okay, to find out the inverse, you swap x and y. So what will be x? X equals to 9 minus 5y. Now solve for y. How do you solve for y? Subtract 9 and then divide by negative 5, right? Subtract 9. What do you get? You get x minus 9. X minus 9 equals negative 5y. So divide by negative 5. So y equals to, you get y equals to x minus 9 over negative 5. Okay, so this is f inverse x. So f inverse of x equals to that value. You can write 9 minus x over 5. That is the f inverse x. Okay, guys. Now the next thing what we want to do here is basically we want to draw the graph of f and f inverse. How the graph of f look like? Let me use one color for graph of f, because when you said y equals to 0, you will get x equals to 5/9. Okay, sorry, 9/5. That will be almost like this is 1, this is 2, somewhere here. Okay, 9/5. And then if x equals 0, that is y equals to, so if x equals to 0, let me do, this is like 5, this is 10, right? If x equals to 0, this is x-axis. If x equals to 0, this is y-axis, then y equals to 9. If y equals to 0, then x equals to 5/9. Let's say 1, 2. Somewhere here. So the graph of the function fx look like this, like that, fx. Okay, now how do I find out the graph of 9 minus x over 5? When x is 0, it is 9/5, and then so it looks like this, right? It is just a reflection, right? So the graph of this will look like the reflection of this. It'll look like this, right? It will look like, let me see. You know, this, if you graph both of these functions in calculator, you will get the nice graph. But here, you see that this distance is, I'm taking 1, this is like 2, like that. But this should be 1, 2, and then you need a bigger space there, right? So it'll look like this. The graph of that look like F inverse look like that. Okay, the shape is right, but the unit is not right. So if you draw the graph, then you will see the how the graph look like. Okay, so what is the domain and range of F? What is the domain of F? So domain of F. Domain is all possible values of x. Okay, domain is all possible values of x. So any value of x is okay here, right? So that is negative infinity to infinity. Do you remember from college algebra that domain of F and range of F inverse are the same thing? So range of F inverse, they are the same thing. Okay, similarly, range of F is equals to what is the range of F? Range of F is equals to domain of, because it is hard to find range of a function. Okay, so to find out the range of a function F, you first find out the inverse and find the domain of F inverse. This is F inverse, right? What is the domain? All possible values of x. So again, any value of x is okay, so that is also negative infinity to infinity. Okay, so I will give you one more example on finding the inverse and domain and range, and I'll give you a applicable application problem. Okay, so let me write down the question first. Alright, let us do question number 41 from the book. Okay, here fx equals to root under 4 minus x square, where the domain of x is between 0 and 2 only. Otherwise it will be negative, right? If x is bigger than 2 or smaller than negative 2, it will be negative. That's why the domain is between 0 and 2 only. So what is the inverse then? So it is like, you can write y equals to root under 4 minus x square, right? So to find out inverse, what do? You swap x and y. You write x equals to root under 4 minus y square, and then you try to solve for y. How do you do that? You square first. X square equals to 4 minus y square, right? And then just add y square, subtract x square. You will get y square equals to 4 minus x square, right? So since x is between 0 and 2, what do you get then? So because if you square this, it is a circle. It will be like this, right? And you are looking at this piece only. You see that? You are looking at this piece between 0 and 2. Okay? So how would the inverse look like? The inverse will look like, the inverse will, this piece has the reflection, this piece, this piece. So basically inverse is the same thing. That's why you got y equals to under the root 4 minus x square. If you take the square root here, you will get that same thing, right? You see that? You will basically get the same thing. So the inverse of this piece is that piece itself. Okay, that is the inverse. So if you graph, that's what it is. If you graph this, you will basically get that this is 2, 2. So the f and f inverse have the same graph. So what is the relationship? How do you write that relationship? Find the relationship between f and f inverse. So the graph of f and f inverse are the reflection of one about y equals to x line. That's the relationship between those two, right? Find the domain and range of f and f inverse. So what is that? So let me write down domain of f, which is same as range of f inverse. Is it same as 0 to 2? 0 is lesser equals to x is lesser equals to 2, right? And then what is the domain of f inverse? Is always same as range of f, right? So domain of f inverse, this is f inverse function, so which is same as that. So it is again 0 is lesser or equals to 2. Do you remember the another way of writing that? It is 0 to 2 in the bracket, right? Both are 0 to 2. Okay. All right. So the very final example is question number 49 from the book. So you need a total of 50 pounds of two items costing 1.25 and 2.75 per pound. Okay, so write equation for total cost y. How do you find out cost? So y will be the, let's say, let x is the number of pound for the less expensive one, less expensive item. Okay, so what is the total cost of the less expensive? This is the less expensive one, this is the more expensive one per pound. So if x is the total weight of the less expensive, so the total cost will be 1.25 times x, right? So 1.25 times x plus, so what is the weight? What is the weight of the more expensive? The total weight is 50 pounds. So 50 minus x times 2.75 is the total cost. This is the cost of less expensive. This is the total cost of the more expensive one. So the y is the overall cost of the total cost, right? So of the whole thing. Okay, so what is the value of x? X cannot be bigger than 50 because x is the weight of the less expensive, because the total weight you want is 50. So 0 is lesser equals to x is lesser equals to 50. That is basically the value of x, possible value of x, because you cannot have more than 50, you cannot have less than 0 pound. Okay, all right. So if you simplify this, what do you get? If you just use calculator or simplify this, because how do you simplify? You just multiply 2.75 times 50 minus 2.75 times x, and then you work with that, right? If you do that, you will get 80 minus 0.35x. That's what you will get. Okay, if you simplify this using the calculator. Now find the inverse of the cost function. How do I find out inverse? This is y equals, right? You want to swap x and y. So x equals to 80 minus 0.35y, and you solve for y. What do you get? If you solve for y, let me write down. If you solve for y, you will get y equals to, you should write like 80 minus x and then divide by 0.35, right? That's what you get. Because how do you get that? Is you write if you move this x to this side and then move that to other side, 0.35 y equals to 80 minus x, right? And divide by 0.35. So what does x stands for here? So here x stands for that y there, right? So x is the cost. So x is the cost. Okay, so here y is the y is basically the pounds, right? So lb of less expensive item, pound of the weight of less expensive item, because we just swap x and y. That is the reason. So what is the inverse? Find the inverse of cost function. We found that, right? Now we need to find out the domain of f inverse. What is the domain of f inverse? So it depends on the values of x, right? So what are the possible values of x here on f inverse? This is y equals to f inverse, right? That is 80 minus x over 0.35. So where y is the pound, the weight of the less expensive item, right? So what are to find out the possible values of x, which is also called domain, we need to know what are the possible values of y. Here y stands for the pound, the weights of the less expensive item, right? So the less expensive item can be as few as 0 pound and as much as 50 pound, right? So when y is 0, because we have y equals to 80 minus x over 0.35, right? When y equals to 0, then you will get x equals to 80, okay, because you said 0 here and then multiply by both sides by 0.35 and then solve for x. You will get x equals to 80, because our goal here is to find out the possible values of x, okay. So we use the possible values of y to find out the possible values of x. So when y could be 50 pound, right, when y is 50, you plug in 50 here and then solve for x, okay. You will get 50 equals to 80 minus x over 0.35. So if you solve for x, you will get x equals to 62.5. So what is the domain then? So the domain is x can be at little as 62.5, right, and then x can be as big as 80, okay, or that is basically the cost here. That's what you get, okay. That is the domain of f inverse. Now if the total cost is 73, how many pound of less expensive item was there? So here the cost was y, right? So you just plug in the value there, or you can plug in here too. Either way you can find out that, okay. So let us do that. You can find out on here, because it says the total cost is 73, okay. So what you do here is you just basically what is cost, x is cost, you can plug in here or here. It's the same thing, here or here, okay. It's the same thing. Let us do that part. So let me use, so y equals to 80 minus x over 0.35. What is the cost here? X, because I'm using the inverse function, right? So if you take the inverse function, x is the cost and y is the number of pound. But if you want to take this function, then you can put y is the cost. So you can put 73 here and solve for x. It's exactly the same way, okay. So y equals to 80 minus 73 over 0.35. If you do that, you will get y equals to 20 pound, okay. So that is the answer. All right guys, so that's the end of section 5.3.